Okay, UML class diagram. So this approach is under the object-oriented model. Okay, so the class diagram, okay, is a static diagram. So it represents the static view of an application or any activity, business activities or system. In easy understanding, it is representation of the system, one system. Okay, so the class diagram is not only for visualization, okay, describes and documenting different aspects of a system, but also for constructing as executable code of the software application. So this is the goodness side of the class diagram, because more information is included in the representation. Unlike the ER gives us same the static diagram, but it contains less information rather than the class diagram. Okay, it contains it describes the attributes and together with the operation of the class. Okay, also the constraints. Okay, so this is the uniqueness of the class diagram. It not only explains the attributes but also give us a operation. So it makes it easier to execute in their software. Okay, for the software application. Okay, so this is the view of the class diagram. You learn this during the object-oriented, right? Okay, object-oriented class. Okay, so I hope you remember this information. We have this rectangle with the object name or class name, okay, together with the attributes. The attributes. For example, here is ID. This is the data type. The name, gender, and birth date. Okay, and this is the data type. Data type. Okay, right. And then similar with the ER, they combine or they connect objects or class. Okay, using this one relation. Okay, this is the same. So, but in the class diagram, we name it as an association. How the object or class visit associates with the patient, for example. How the employee associates to the company. So book is associated with the library. Okay, namanya macam sama saja, cuma the label, the term is given, and then we can from the given term we can quickly understand that this is for object oriented, this is for relational. Okay, so that is the only the term, but the function is all the same. Okay, so the class and object, you know, it is like an entity in the ER. Okay, entity in ER, the same. Okay, the attributes. Okay, the attributes, and also we have the composition, we have also the cardinality and also the degree. That's all the same. Okay, they also have the many to many and many to one, the degree of the relationship itself. Okay, so the class diagram are widely used in the modeling of object-oriented, sure, because they are the only UML diagrams which can be mapped directly with object-oriented language. So the class diagram will show us a collection of classes, interfaces, associations, collaboration, and also the constraints. Okay, so this is what the class diagram should show to us. Okay, so other name is a structural diagram for the class diagram. So the basic purpose of any model actually is to model or to give a static view of an application. So this is the general purpose of, I think many model give this kind of purpose. Yeah, because the function of model is to give a static view. Static or dynamic view is never mind. We use model to give the overview of an application or system or situation. So this class diagram, the purpose, the first one is to analysis to give an analysis and design of the static view of application, and then they can be used to describe responsibility of a system, and then it can be also be used as a base for component and deployment program, and they can also be used for the forward and reverse engineering. So this is the main purpose of the class diagram. Okay, what are some things that are not represented in a UML class diagram? Okay, your class diagram will not give you the details of how the classes interact with each other. Okay, algorithmic details, how a particular behavior is implemented. So these two things is not given in the class diagram. Okay, it only gives you how the class associate with other class, but the details is not given. The how is not given. Okay, only the cardinality and also the association is given. Okay, so how to draw the class diagram? You know this, right? Okay, I should give you some the case study and ask you to draw, but this is a refreshment. So the class diagram, the points, you need to remember how to draw the class diagram. Usually we use the software that is ready-made, so you just give the information and they will do for you. Okay, the diagramming will be done by the software. It easier. Okay, so what are the important points you need to remember before you draw the class diagram? The first one is the name of the class diagram should be meaningful. A meaningful name. Okay, you should decide the name, and the name of the class should represents the object itself. Jangan bagi nama yang selain daripada yang tak menggambarkan objek yang diwakili. Okay, so the name is very much important and must be represents the object. Okay, each element and their relationships should be identified in advance. Okay, maksudnya ni kita dah kenal pastilah, dah buat dahulu, dah identify dahulu beforehand, before you create or draw the class diagram. Bukan nak draw, nak lukis baru terfikir-fikir apa nak masukkan. Itu dia akan jadi silap lah biasanya. Then responsibility, that is attributes and methods of each class should be clearly identified. So this should be the same. You need to identify those things. Okay, prepare in advance before you start to create the to draw the class diagram. Okay, for each class, minimum number of properties should be specified because unnecessary properties will make the diagram complicated. Okay, minimum number of properties. Okay, so diagram of one class example. Alright, class name in top of box. This is the class name. Okay, class name. Class name, okay, write interface on top of the interface name. Use italics for an abstract class name. Okay, attributes. Attributes is optional, but actually we need not really optional. We need to give an attributes to the class. Okay, operation or methods. This one may be optional. Okay, but do not omit any methods from an interface. Should not include inherited methods. Okay, so again the same like ER. We have this is the attributes. And extra, this is the method or operation. Okay, so for example, this is a class rectangle. They have attributes of width, data type integer, they have a height data type integer, and then they have then area data type double. Same goes to the class student. Okay, class student. We have this name, the student ID, total number of student, okay, and so on. So this is the example. Yes. Inheritance method. Okay. Usually we have methods. Okay. For example, in class subclass parent and child, right? Okay. So parents have a method like what? Parent have a method like giving what? For example, maybe they are hair color, for example. It is inheritance inherits from the parents. This is the natural example, because parent and the child. So the kids also can inherit this one to their kids. Okay, to the grandchild. So this kind of inheritance method is happening also in the object oriented. Okay, yeah. Yes, that this is protected means that ni kan yang public dengan private. Protected is given to some specific. Kalau private, totally private. Protected ni kadang-kadang kita beri kepada satu-satu situasi ataupun satu-satu method yang lain yang kita nak. Okay. Okay, so this part, the attributes, visibility, we have visibility name, and then the visibility, we have visibility of the class itself. This is the what ER doesn't have. Okay, they have the class object visibility. We have a public, we have protected, we have private, we have also the default package and also derived. Okay, so we have various kind of the visibility, and somehow it is defined in the diagram, in the class diagram. We can see these features in the class presentation, but not in ER. ER maybe they have, but they are defined in other way around, not in their diagram. But here in the class diagram, we can see. Okay, for example, here we can see the visibility of the class method. Okay, we can know. Okay, whether it is protected, public, or somehow private and default and so on. Okay. So derived attribute is not stored but can be computed from other attribute values. Okay. For the public, yes, any can access the method, but private and also protected looks like similar, but in private visibility for the class, the type of it can only be accessed by code in the same class. Okay, but the protected is it can be accessed only by the code in the class or that is derived from the class. So the protected means that the derived method, okay, of the same class can also access this one, okay, this method. Okay, so there is a difference between the protected and also the private. Okay. Next is an operation. The previous one is actually for the attributes, and this one is for the class operation or method. It brings the same features, especially on the visibility. But this one, they for the operation or methods, they have the parameter, and then they omit the return type on the constructors, and when return type is void, so it goes to the class operation. Okay, right. Next is an associational relationship. So we call it as a association. Okay, the relationship. Okay, we have multiplicity, how many are used, and then we have the name of the associations, and also the navigability, the direction. So this is how class A is associated with the class B, the class B. So we have a multiplicity. This is the various option we have. Star. Star means 0 or 1 or more. So means many. Like many in a ER. Okay, many. Right. 1 is exactly 1. So here 1 dot dot star represents 1 to many in ER. And in the ER. Okay, 1 is exactly 1. 2 to 4, between 2 to 4, inclusive. Inclusive means 2 and 4 is included in the range. And 3 to star, 3 or more, 3 to many. Okay, it is the same like the ER. AR also you can define it any number starting from 2 and above, not only 1. Okay, but usually in ER they just mention 1 to many, many to 1, like that. Okay, because somehow it is difficult to obtain the precise value of this for the multiplicity. Okay. So this is the types, the kinds of association multiplicity. We have first type is 1 to 1. So each student, for example, must carry exactly one ID card. So look here, one student carries is an association, only one ID card. Okay. ID card. So this symbol is a direction. So we read from student to the ID card here. Okay. Yes. This diagram, class diagram. No. ERD. Okay. ERD is under what? Relational type of database. Relational database. But class diagram is under object-oriented database. Can you understand this? Okay. But the purpose of these two is the same. Okay. And they want to give us the structure of our database. Just the approach is different. The approach is different. Okay. So in relational database, the ER diagram, also we have also entity 1. We connect with the entity 2. Okay, entity 2. Remember? So the difference is the naming. So this is entity. But in the OO, we have object to object. Okay? And these two also must be connected. Must be connected. And the connection here is named as a relation. But this one is known as an association. Okay. And for this one, the degree, okay, or the cardinality, we have one to many, many to one. Remember, many to many. Same goes to here, but only the symbol used, okay, the syntax used is different, but their purpose is the same. That is to give a database model, to show, to represent the database model structure. Can you understand? Yes, same. We have direction. We have the cardinality. We have a relationship. We have the what is this? The attributes. Okay, but in the OO we have operation. In ER we do not have the operation or method. Okay, so I'm teaching you, this is the two methods of diagramming or modeling the database. So in this class, you will learn these two types. Because of what? Next semester, this is for the short term goal. For next semester, you are going to perform your final year project. So in final year project, you are going to be asked whether you are doing the system design based on structured or object oriented. Do you ever heard about this? Structured or object oriented? If you are going to develop an apps usually, so you need to use an object oriented, because the programming language that is used to perform to build the apps is using the object oriented. So the design beforehand, you need to design it using the object oriented. Okay, so if you are developing the common systems, okay, system using PHP for example, so you may use the structured approach. Structured approach means it falls under the relational database. For the database, it will use the ER. So this is for the short goal. For the long term goal, when you are going out to become an analyst and so on, programmer and so on, you need to know the design of the system. Any system follow which structure, whether it is structured or object oriented. Usually now we have these two. So you need to understand this one. If you are using the structured, what database design you need to draw? What system design you need to produce? If you are using object-oriented, the same. What design you need to produce and what database design you need to draw. Okay, so this is the knowledge that you need to know before performing this one. But in this class, we are giving you all the underlying concept. Okay, but the selection will be done during, for example, for the project, for in future when you are working out and so on. Am I clear to you? Okay. 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 This is the multiplicity constraints. Okay, this is what that has been explained previously. Okay, 0 to 1. Okay, is 0 or 1 entity occurrence. 1 to 1, exactly 1. Okay, 0 to star. Okay, or just star is 0 to many entities, many. Okay, 1 to star is 1 to many. 5 to 10, yeah, it is very precise. They provide a scale 5 up to 10 maximum, and then 0, 3 is optional. Okay, 0, 3, and a range from 6 to 8. So this is the example of various multiplicity constraints in association. Okay. For the structural constraint, multiplicity is made up of two types of restriction: cardinality and participation. Okay, you learn the cardinality in the ER. Okay, it describes maximum number of possible relationship occurrence for an entity. Okay, maximum. Like the previous example, 5 to 10. Other example, this class, okay, for example, FSKTM, the section, only 1 to 35 students are allowed in one section, for example. So it gives us a number, okay, a precise range that is possible for that relationship. Not student. Yeah, student and section. Section up to. Then relates to the class. Class relates to the lecturer. Lecturer relates to the program. So that is the situation. And participation determines whether all or only some entity occurrence participate in an relationship. For example, again the same. All students must have their ID. For example, student ID. Of course, kan? So it means all students must. Okay, but some students may join the competition. Some students. So it defines that only some students may join the competition, not all. Okay. So this is the participation definition. Okay. Multiplicity as cardinality and participation constraint. Okay, so this is an example. What is this? So this is a class staff, and then this is a class branch. So staff manage branch. Of course, staff manage branch. Branch is managed by the staff. Okay, this is a cardinality. One branch is managed by one member of staff. One branch is managed by one member of staff, and one member of staff manages one branch. So this is the cardinality. And participation. All branches are managed by all branches are managed. Means that all branches must be managed by somebody. But not all staff manage the branch. Only selected staff can represent become a representative to manage the branch. Okay. Can you understand this one? So all branch are managed mandatory by staff. Okay. But not all staff here manage the branches. Okay. Example, in student class. Okay. Every class must have student representative. Okay. But not all students will become a class representative. That is a example. Okay. So this is the summary, okay, of the class diagram. Okay. This is not new for you because you learned it in previous class, object oriented. So you need to revise and recall back your knowledge about the class diagramming. But in this database class, we give a focus more on the relational model ER rather than this class diagram. Okay, so this we have a class, abstract class, multiplicity. This is aggregation, composition, and so on. So this is superclass, subclass, and so on. Okay. Example. online shopping example. Okay, so how many class we have? 2, 2, 4, 6, 8, 10. This is example. So we have a class object web user. The customer must have an account before they can make an order, a payment, shopping cart. Okay, the shopping cart have a line item, means the queue. Okay, the product order. Okay, then what's next? So this is the basic relationship or basic objects or class that may appear in an online shopping situation. Okay, so for those who are creating online shopping, okay, so you may follow and take some structure from this one. The basic structure is this: customer, account, order, payment, product, shopping cart. This is a new line item. Okay. Library system. Library system. Any of you creating a library system? Okay. So this is a librarian. They have the alert member, whether it is faculty member or student member. Okay. So they have book. They manage book, reference book, general book. What is left behind? Returning, borrowing and returning, right? Information. It is not included here. Borrow and return the book. Here they have return date, but we do not know who is borrowing the book because we do not keep the data. Okay, so something is missing. Maybe this is just basic structure for the member to look for the book only, to search information for the book only, because we have a catalog here. Okay. Next example is what? Organization management. For this one is for the hospital. Hospital has a department. Department is managed by the staff. Okay, and the staff, we have administrative staff, front desk staff, receptionist. So this is the structure. Maybe it is kind of a subclass and also superclass situation. Okay. Why do not have? Because they inherit maybe some attributes from the superclass, each superclass. Okay. So tools for creating UML's diagram. Usually we use a rational rules. Visual also can be, but maybe they lack of specific notation to create the diagram. Rational rules is the best because it is developed for this purpose, object oriented. Violet I never use. Maybe you have, or if you have any tools that you are familiar with to create the UML diagram, so you can share. Okay. Saya biasa guna rational rules. Cuma rational rules semua yang tu biasa ada license lah. Rational rules is purposely created for object oriented. Jadi dia punya feature semua memang dah cantik lah, dah kita tak payah nak tambah apa lagi, cuma nak define saja. But if we are using other software, somehow is lacking with the object oriented punya notation. Itu sajalah dia punya kelemahan. Okay, but still can do, but you need to edit by yourself. Okay, so where to use the class diagram? the class diagram is also considered as the foundation for component and deployment programs. Okay, we need to visualize that one. Okay, and again, so this is actually the recap. We want to show it. Of course, it describes the static view of any system you want to show, and then it shows the collaboration among the elements of the static views. Okay, and also we describe the functionality performed by the system, and the construction of software application using object-oriented language. Okay.